Hello, let us continue our discussion on the resource description framework. So, in the last lecture about resource description framework, we have talked about how do we model this RDF as in a graph formalism and what are the kind of serialization techniques or formats that are there to represent this abstract data representation into a concrete form. And now let us focus on something which will let someone to express bit more complex needs, right? So that the first kind of construct that we'll be focusing on are called the containers. So these containers, they are of two types. One is an open container, other is closed list, right? So in open container, what we have got unspecified number of resources or the literals that can come into a container, and this container is really representing a group. And now as as many as elements you can have in this group, so you can keep on adding the members to this group. So that's why it's called an open group, right? And it might have duplicate entries as well, right? So there are three types of containers that are allowed in RDF. One is RDF bag, which is basically representing an unordered group of resources or the literal. So the elements that you can have in a bag, they are unordered. There is something called RDF sequence or RDF sec, which is basically a ordered group of resources or the literals. And there is something called RDF alt. So whatever values that you are having there or elements you are having there in the group, they are alternatives to each other, right? Now let us take each one of them and try to illustrate them with some example, right? So the first example that I'll try to model is the Indian cricket team has Virat Kohli, Rohit Sharma, and Mohammad Sami as players, right? So this is what I'm trying to model. Like Indian cricket team has players, so these are the players in Indian cricket team, and we know you don't have any order. You can first say Rohit Sharma, then Virat Kohli, then Mohammad Sami, or first Mohammad Sami, then Virat Kohli, then Rohit Sharma. So any permutation you can think of, you can represent them like that way, right? But if you take any such permutation, so Virat is coming first. So you say something like RDF colon underscore 1. So this is the first relation or first element in the container, though it is unordered, but you need to serialize in some form. Uh, RDF2 is again a relation that relates these bags. So this is a bag, right? So this is again one anonymous node. Anonymous node. So you don't know what is that bag actually. It has got no identity, but you know certain properties like it contains Virat in the first position, it contains Rohit in the second position, it contains Shami in the third position. So these are kind of special relations which will allow you to present or represent the groups, right? And of course, you need to say that it has got type to be RDF bag, right? Now these are called container membership properties. So these are, I'll not say these are called, these are the instances of the container membership properties. So these are properties because they are they are coming as the labels of the edges. So that's why they are properties. But what kind of property they are? They are designating some membership in a container, right? So I'm saying that Virat Kohli is a member of this container, and this container is of type bag, right? So how can you write that in XML form, RDF XML form? So as we have done earlier, we have declared the namespaces. We are describing about the Indian team. Now we have done something else here than we have done in the earlier RDF XML specifications. So in earlier documents, we used to write the entire URI here. You can shorten that as well. So for that, you have to say something like this in the description, like you have to say that exr means this, so you cannot define that in namespace. So this is something very much tied to this XML RDF XML representation. So you have to do this in order to shorten this RDF description URL, right, about URL, right. So but the main point of focus is the has player. So the has player has got a value. So this is the subject, this is the predicate, and this is the object, right. And this object is represented as a list. So the first element in the list is Virat, second element in the list is Rohit, and the third element in the list is Shami. Now what you can do, so you can copy this particular piece of text, and you can put this in something which is called one RDF validator. So what it does, it validates one RDF XML document and creates a table out of this. So it will, you can see that it creates a table for you, given that the XML document that you are putting there, or the RDF document you are putting there, is valid. Now let us model something like this. The innings was played by Dhawan, Rahul and Virat, and in that order. So first comes Dhawan, then Rahul comes to bat, and then Virat, right? So this is an innings, which is an innings X, which has got batsman to be the first to be coming is Dhawan, the second one is Rahul, and third one is Virat, and it is modeled as RDF type. RDF type to be the sequence type, RDF sequence, right? So one would have expected that, well, as I have got RDF sec written explicitly here, the application should understand them to be the sequences. But you have to be a bit careful. It depends on the parser of the document. So to process these RDF documents, you need to have parsers, right? So you need to have parsers to parse, to understand to understand the RDF documents, right? So it depends on how the parser has been written, whether they understand the sequence in the proper semantic subsequence, right? You need to be careful there. Now the third one is the alternative one, right? So here I'm trying to model the Indian team can have the wicket keeper to be one of MS Dhoni, Riddhiman Saha, or KL Rahul. We know that in an innings you have at most one wicket keeper playing, right? So this is how I'm modeling. So Indian team has wicket keeper, the first one being Dhoni, and then Rahul, then Riddhiman, and you make use of or play one of them, right? Now this open containers, they are kind of open group where you can add elements, but in some cases you want the collection to be closed, right? So the list to be complete. You don't want anyone to enter that list. So if you think of the players who are fielded in a particular match, right? So you know that we know there are exactly 11 players, and we cannot have 12 players in the game for a team, right? So in that case you have to model that as a closed list, and these closed lists are called closed collections. So let us take another example relating to cricket, an Indian cricket team. So that is Mohammad Shami took wickets of David Warner, Steve Smith, and Aaron Finch in that order, right? So this is how we will be modeling. So the wickets of Shami, this is a list, and this list, as we have mentioned earlier, has got two parts. One is the first, and second is the rest, right? So the first, I can just mention that RDF first to retrieve the first element, which is basically Warner, and we have a rest, and this rest again has got two elements like Smith and Finch, right? And what you can say, you can retrieve the first element from here, and the first element of the rest is Smith, and the last element in this list is Finch, right? And all this particular anonymous node, this particular anonymous node, and this particular anonymous node, they are all type of lists. So these are all lists, and finally the rest is nil, and you stop here, right? So you know that you have come to the end of your list, and you stop your parsing. So here the construct of representing this in RDF XML would be a bit different, of course. So this is the subject that I'm talking about. This is the predicate, which is basically talking about the wickets. So this is of type collection. This is what we are writing here in the XML as XML attribute, right? And this, what are these entries in this collection? So Warner is the first entry, then Smith is the second entry, and Finch is the third entry. So again, you can put this in the XML validator and check what kind of information you can get, a tabular information you can get if the XML document is valid. Now, in many cases, you might want to represent a statement about a statement. So, someone can make a statement about a statement. So, for example, let's say one politician has made a statement, and another newspaper, they are making another statement based on the statement by the politician, right? So, these are called the statement of statement, or in technical term, they are called reification, right? So this is in technical term we call reification. Let us take an example from the Harry Potter. So the example goes like this: Arthur Weasley suspected that Lucius did actually support the Dark Lord. So this has got two parts, right? So Arthur Weasley suspected. So this is one kind of statement. And suspected what? And suspected, and this uh, this is another statement, right? So Arthur Weasley suspected something, and what is that something? That Lucius supported Dark Lord. So how to represent this in RDF? And that will be doing using something called RDF statement. So what is the structure of RDF statement? An RDF statement comes with these three things: RDF subject, RDF predicate, and RDF object. Now, if you think of any sentence or any statement, it has got three parts as far as the RDF formalism is concerned. So you have a subject. So here Lucius is the subject, and you have the predicate where Lucius is supporting someone is the predicate, and object is the Dark Lord. So this is the statement, right? So we are making a statement about the statement. So let us see how do we do that. So Arthur Weasley suspected something, and this something has got subject to be Lucius, predicate to be supported, and object to be the Dark Lord. And the type here would be our type for this particular anonymous node would be RDF statement, because it is representing a statement. So this is the first level of the statement, and this particular thing is the nested statement under this statement. So this is statement 1, and this is statement 2, and this statement 2 is included into statement 1. And this is how we can represent a statement about a statement. So how we can represent the same thing in RDF turtle representation? So Arthur Weasley suspected something. So this something really representing this. So this is your ABC. Now, even if you don't assign anything, your system will pick up some value, right? So this ABC is of type. So this A means RDF type. So this is a shortened version of RDF type, right? This is a type of statement, and the subject of this statement is Lucius. The predicate of this statement is supported, and the object for this statement is the Dark Lord. Now you can see that we talked about many things like, say, RDF type, RDF bag, RDF sequence, RDF alt, RDF list, RDF property, etc., etc. So these are called the vocabulary of RDF. So these are RDF vocabulary items, right? So we can define these properties like this RDF type, RDF bag. So this entire specification of the vocabulary you can find in the URL that we use in the RDF namespace. So you can have a look at that. But to summarize, there are different classes. So this RDF property is the class of all the properties, or the other way to say this is that it is the set of all the properties, right? Again, RDF statement is again another class. So it is a set of all the RDF statements, right? And if you have something to be a class, then you can have an incoming edge to that class to be, say, RDF type. To designate something, this something, say S, to be an instance of this class, right? So that is how we can recognize a class. So these classes are also called concepts, and they are represented mathematically as sets. Now you can have RDF XML literals. So these RDF XML literals are like the different kind of data types, integer, strings. Those are XML literals. You have classes like RDF sequence. As I have mentioned that if you have something to be class, then you may have one incoming edge like RDF type. And you have seen in the examples that this anonymous node which were representing the bags, they were having an edge to the RDF sequence or RDF bag to RDF alt or RDF list, and having this RDF type relation, right? Now there can be properties. So this RDF type is the properties, and best way to recognize the properties is this, like these properties, they appear as the labels of the edges, right? You go to the graphs and you see that all these properties that I'm mentioning here, they are coming to be the labels of the edges. So RDF type, you can see that we have used this RDF type to be the label of this edge. RDF subject we have used in the reification, RDF predicate, RDF object. All these are the kind of properties we have used to relate to nodes, right? And RDF first, you can see that is also coming as the level of the edge, RDF rest, RDF end. So these are the container membership properties, right? So these are also kind of properties. And finally, you can have resources like RDF nil, which is a reserved thing, right? So this nil means you are, this is a kind of null object equivalent in C or C++, right? Or in Java also. Now, whenever we have something like RDF type and a statement like A RDF type B, we say that A belongs to class B, right? So we say that A belongs to B S, where BS is the set theoretic representation of the class B, right? Now this all the properties you can think of, they belong to the class RDF property. So don't go by the name property. Though it is written like RDF colon property, it is a class. It is a class. It is the class of all the properties you can think of. So if you say that P is RDF type property, so that means P is a property. P is an instance of a property. If you can think of, say, has brother, has father, has mother. So these are the properties, and you can assert this fact that has brother is RDF type, RDF property, right? And in that sense, RDF type has got RDF type to be RDF property, right? Because RDF type is also a kind of property, and this belongs to the class RDF property. So that's why we can assert this statement, RDF type has got type to be property, or in other statement, RDF type is an instance of RDF property. Now RDF, this is a very simple way to represent the knowledge about your domain, but it has got no capability to do any sort of inference. So let's take a very small example to illustrate why RDF cannot do that. Let's say Fabian is a man, which is, we know this is true. And in general sense, if we know this, we will be able to infer that Fabian is a person and Fabian is a living being, right? Now you can see the set relationship between these three classes: man, person, and living being, right? So man is a subset of person, person is a subset of living being. Now, if you want to represent this in uh, RDF, you have to state them explicitly, right? Like Fabian is a type of person, Fabian is a type of man, or Fabian is a type of living being. Even though it is very much easy to see as human being that if we just say that Fabian is a man, from that we can infer Fabian is a person, and from that we can infer that Fabian is a living being. So we don't have any inferential capability in RDF. Now, how do we ensure that this happens? Only thing we can say that M is a subset of P, or P is a subset of L. This is what we can do. Now, this subset relation is represented in RDF to be the subclass of. So, M is a subclass of P, or P is a subclass of L. But that kind of vocabulary item is not existing in RDF. So, for that we need something called RDFS. So next we'll be talking about RDFS. So before going to that, if we talk about knowledge about any domain, the knowledge can be separated in two distinct parts or types. One is called an assertional knowledge, so where we are really asserting some statement to be true. So for example, Jane is a mother of Fabian, right? So this is what we are asserting to be true, and this concerns mainly concrete data items. So these are called assertional data items or assertional knowledge. But there are certain terminology which are understood in that particular domain. So if we talk about the kinship domain, we know that there is a concept called mother, there is a concept called woman, there is a concept called man, there is a concept called person, there is a concept called living being, and they have relationships between them. For example, mother is a woman, woman is a person, man is a person, mother is mother of some person, and person is a kind of living being, right? So these are the terms that you understand in your community, and these are the relations that you know they are holding true in your domain irrespective of any concrete data. So even if you are not supplied with any concrete data, you understand the relationship between the concepts and the concepts themselves in your domain, right? So these are called the terminological knowledge. So this part is well captured by RDF, but this part is not really well captured by RDF, right? And this is where RDFS comes into picture, right? So you see, we can express, or we can do more thing, we can do more thing than what we can do in RDF, but there is a cost associated to it. So what is the cost? So you need to apply more other algorithms. So the data processing here would be much more easier than the data processing here, because you need to take care of these relations while you do something about the data, right? So this is the kind of trade-off that you will always be having. If you increase the expressivity of a language, the processing cost will be increased also, right? So here you can see that we can infer that Fabian is a person and Jane is a mother, right? So this is your data and this is your schema or the terminology. So in semantic web language, this is called a schema. So if we talk about a schema, so schema is basically you have a domain and you know that domain has a conceptual structure, right? And this conceptual structure is represented using this terminological knowledge. And this schema is basically a tool to let you express this terminological knowledge. So this schema is a tool to express this terminological knowledge. So you can think this schema to be a template of your data, right? And this RDF schema is basically, it is a kind of a tool to express the terminological knowledge concerning RDF data, right? So basically this, if you have this terminological knowledge, it is kind of structuring your data. It is kind of structuring your data. It is kind of organizing your data. It is kind of organizing your data, right? So let us try to see what kind of things we can do in with RDFS, and going forward we'll be talking about different elements that are there in the RDFS vocabulary, right? So we can express in RDF like John has got type to be student. That means John is an instance of student. But what is a student? How do you represent the semantics of the student? Now, as we have already mentioned that RDF do not have the vocabulary to do that. So conceptually, what it is like, that student is basically a set which is representing a concept or a class, right? Now, we can explicitly say that student is a class, right? And not only that, we can also say that the student class is a subclass of person, right? Or again, we can also assert some properties or define certain properties, like uh, a person has a property which is called has name. So we can define the class and the subclasses, and also you can define the properties, right? And each property, what are the kind of meaning that is associated with that property. So we can do all these things using RDF schema, right? So how do we assert that something is a class? Just by saying that student which you are trying to define is an instance of RDFS class, right? So this is a class, right? So this is a class you are trying to define, but this is an instance of the RDFS class. So RDFS class, again, it is becoming to be a class, and this student is also a class, but in another sense, it is acting as an instance of this class. Instance of this class. Why is that? Because everything is a resource, right? So this is also a resource, and a resource by all means can be an instance of another class, right? So these are kind of things that you need to be involved when you think about all this. So in the first go, it may be sounding to be tricky, but as you are conversant with the language of the semantic web, these things will become more or less clear going forward. So you need to always think about everything in a set theoretic way. So this RDFS class is a class, right? So it is a class of all the classes, and now student is a class. So student class is a member of the RDFS class. Now, if something is a member of a class, then we can write a statement like this, like the student has got RDF type to be RDFS class. Now, you might note another very interesting thing that we are doing very unconsciously, that we are representing everything, the semantics. So the asserting one data item, or asserting a fact, or describing certain attributes of something, or defining the classes of the concept, defining the properties, everything we are doing with this help of SPO structure. You can see you have got this SPO structure. This student is the subject here, RDF type is the predicate here, and RDFS class is the object here, right? So this is another interesting thing that you might want to note. You can also define class hierarchies, like saying student is a subclass of the person class, right? Very simple to follow. Now this has name is a type of property, which is very true, of course. Now you can also define hierarchies among the property. So you can say that has mother has is a sub property of has parent. You know this is true, but you have to explicitly mention that or assert that in your knowledge base. Otherwise, it will not be inferred automatically. Now, whenever you are uh, mm, associating certain properties with the classes, so you have something like say student, this is a class and they attend say lectures. So lecture is a class, student is a class, right? So you can you are relating them with attend relationship. So when you do that, there are two distinct things that will basically uh, mm, mm, ex, that will basically make the semantics of the uh, relation explicit. Let us see what are those, right? So the first thing that we can do, that whenever we are saying attend something, so this value that the subject can take, they should always belong to the student class, right? So in that case, we will say that this attend has got a domain to be student. So in this case, we are saying the same thing for has name. So the has name property, the domain should be restricted to person. So I will repeat this word restricted. So the value it can take as subject, that should always belong to the person class. So you are restricting the type of entity that will be associated to be a subject of this particular property. So this is one way to assign semantics or meaning to the relation has name, or in this case meaning to the relation or property attend. There is another part of it. So here I am asserting that has name has got a domain person, right? The other part is the range part. While we are talking about the object, we can also impose similar kind of restriction for the object part of the triple. So we can say that for a given property, what are the kind of values, what are the kind of entities that I can have in the object place, right? So that will give us the range of the particular property. So in this case, I am saying that this XST string is the range. So that means whatever name you can have for a person would be a string data type. But instead of having a string data type, you can have a class itself also. For example, in this particular case, the range of this attend relation is the lecture. So one can attend a lecture, right? And so if you have an instance of this particular template, so S1 attends say L1, right? So by this we can infer that S1 belongs to student, because we know that the domain of this relation is student, and this L1 belongs to this lecture, right? So this is how we can uh, mm, mm, assign meaning to the properties also. So what are domain and range? So they are basically, they restrict the possible values of the objects or the subjects a property can take, right? So if you think the subject, then we talk about the domain. So the subject, this is related to the domain, and the subject of this particular property should belong to a specific class. And for the range, we are also saying that, and range basically relates to object. So what kind of instance the object will be for a class, right? What kind of class the object will belong to, right? So one thing that you need to note that the sub properties, they inherit the domain and range of their super properties. So let us take an example. You have, say, parent of. So what you can say, the domain of parent of is, say, person, and range of parent of is, say, also person. Now I am defining that mother of is a sub property of parent of. So in that sense, this mother of relation will inherit the domain and range of the super property. So the domain of mother of will also be person, and the range of mother of will also be person. So this is the domain and this is the range, right? So let us try to crystallize the thought that we have put forward in the last few minutes. So you have the terminological knowledge. If you talk about any knowledge base, terminological knowledge. So you have terminological knowledge, and you have got assertional knowledge. And this terminological knowledge will primarily concerning will concern like class subclass hierarchy and the property hierarchy, right? But the assertional knowledge, they will talk about specific instances and how these instances are connected to different classes. So this is where the connection between the assertional and the terminological knowledge comes into picture when we say that a particular entity is an instance of a particular class, right? So this is an example of the class hierarchy, like parent is a kind of person, a child is a subclass of person, sibling is a subclass of person, father is a subclass of parent, and so on and so forth. Also, you can assign relationships other than the subclass superclass relationship, like a parent has child, the child is child of a parent, child has father, child has mother, so on and so forth. Now these are the kind of important vocabulary that are pretty much used in describing the resources on the semantic web using RDFS. So you have RDFS resource, which is kind of class of all the resources. So everything is a kind of resource, right? So RDF class is basically class of all the classes. So in that sense, RDF resource is also a kind of class because it is a class of all the resources. RDF literal is basically class of all the literals. You can think of any value kind of things, they are belonging to this class RDF as literal. RDF property is the class of all the properties, and RDF type is a type of property. So it belongs to the class property. RDF subclass, it relates one class with its superclass. RDF subproperty, it relates a property to its superproperty. RDF domain, RDFS domain is used to specify the domain of a property, and RDFS range is used to define the range of a property, right? So let us take another example and try to see uh, the kind of relations different classes they can be having with that other classes. So here we are defining kind of uh, vocabulary for the musician. So you have a class to be musician, and you are defining a class Indian classical musician, which is a subclass of musician, right? And place is a property which has got the domain to be instrumentalist and the range to be an instrument, right? And some musician can perform in the concerts. So performs in is one property, and a musician is the domain of this property, and concert is the range of this property. So this particular RDF XML has been expressed in the graphical form. You can see that a musician is a kind of person, and this is a is equivalent to the RDFS subclass of. Male is a kind of is a subclass of person, female is a subclass of person, musician performs in a concert, and Indian classical musicians, they play raga music, and vocalist is a subclass of is subclass of Indian classical musician, and instrumentalist is the subclass of Indian classical musician, and an instrumentalist performs with a musical instrument. And this is the data part of the knowledge base. We are describing Pandit Hari Prasad Chaurasia, uh, who is an instance of instrumentalist, and he performs with flute. He plays a raga, like Raga Yaman, and performs in, say, Dover Lane Music Conference. And you can see that this is an instance of the concert, of a concert class, and Raga Yaman is an instance of raga music, and flute is an instance of the music instrument. So this upper part is basically defining one RDFS ontology. This ontology we have talked about earlier. It is a conceptualization of a domain, and the lower part is basically talking about the individuals and the instances of the concrete data items which can be expressed in RDF. Now, this RDFS vocabulary, you have got many entries. We have discussed this in the last few slides. Now they have pretty integrate relationships between them. They are many a times they are not apparent, right? Let us see what are the kind of relations that hold between the entries in the RDFS vocabulary. Now we are talking about two kinds of relations. One is subclass of relation, and instance class relation, that is type. So whenever I say that something is of type something, or X is a type of Y, then X is an instance, Y is a class. So as X is an instance, it has got one URI, and also you can say something like X is a subclass of Y, right? So these are the two relations that we will be considering to relate the concepts or the vocabulary items in RDFS, right? So as we have mentioned that RDFS resource is the mother of all the vocabulary items. So it is the class of all the resources. So anything you can think of is an instance of this class, right? So RDFS literal is a subclass of the resource class, right? So as the literals that you can see, they are also resources, right? Now RDFS class is a subclass of resource, right? So uh, mm, mm, also RDFS property is a subclass of resource. So everything is a property is also a resource. Everything that is a class is also a resource. So that is the way you should think, right? So if you have something like this, everything uh, belonging to a, say, concept C1 also belongs to concept C2, then this C1 is a subclass of C2, right? You have something called constraint resource, right? So we talked about the restrictions like domain restriction and the range restrictions. So we are imposing the restrictions using something called RDFS domain or range, right? So these are kind of properties which restricts the value the subject or the object can take. So as they are restricting the values, so these are constraining the values that one can take, one particular subject or object can take. So that's why these are called constraint properties, and as these properties, they are also resources, they also belong to these constraint resources. So that's why we have something called constraint resource, and something that is a constraint resource is also a resource. XML literals, they are a subclass of the literal. So there might be literals outside the XML literal domain. So that's why this is a subclass of the literal class. This constraint property, as I have mentioned earlier, is a subclass of the constraint resource. And this constraint property is also a subclass of property. So if something is an instance of the constraint property, is also an instance of the property, right? Now, there is something called container membership property, which we have discussed while we talked about the bags uh, or the sequences and the alts, right? So there we had something like RDF colon underscore 1, RDF colon underscore course 2. So they basically are used to ascribe a membership of something to a container. So as this is a property, this is also a subclass of the RDF property, right? So I guess we are done with all the relations that are subclass of type. Let us see the other part of it. So the instance part of it. Now this literal is a type of class, right? So that's how we should say. This RDF literal is a type of class. So that's why we have a relation like this is RDF type RDFS class, right? Likewise, we can say that RDFS class is also a type of class. So it is a type of itself, right? Constraint resource is a type of class, right? So this is a class of all the constraint resources. So this is a class, so it is a type class. Constraint property is also a type of class because it is a class of all the constraint properties. And what kind of constraint properties we can have? So I made a mistake here. It should be RDFS domain. So so this class will not be here. So RDFS domain is a type of constraint property, and it will be range. RDFS range, and it will be RDFS. RDFS range would be a type of constraint property, right? Because they are also properties, right? And this RDF underscore colon 1, RDF colon underscore 2, these are all the instances of container membership property. And what do? They relate one instance to and they make it belong to a container, right? So that's why these are called container membership property. So this is also a type of class because this is the class of all these instances, right? So it is of type class. And finally, we can say that RDF type is a type of property, right? So I'm saying that RDF type is a type of property. I'm also saying that RDFS label, this is used to label something, like you have the instance like say Lionel Messi, and you want to say that the name of Lionel Messi is Lionel Messi string, then you can use this RDFS label, and you can see that this is a kind of property. This is a type of property. You can write comments in your RDF or RDFS document, and that is also a type of property. And if you think of RDFS subclass of, this is also a type of property, right? So you relate something like C1 is subclass of C2, right? So this is a property, this type of property. That's why we are writing this type property. And subclass of, you can also say like this. Again, this will be sub property of property of. So you can say that our property P1 is a subproperty of P2. So in that case, this subproperty of is a type of property. Now you can see that the relations that are holding between these RDFS vocabulary items, they are not really very apparent to follow. So you need to think about them a little bit to understand what kind of relationships they are holding. So if you don't understand those relationships, the meaning or the semantics of the individual vocabulary items will not be clear. And that's what this RDFS or the W3C, they really came up with, to provide a very clear understanding of these vocabulary items by relating them with each other. So in the next lecture, we'll talk about the relationship between this resource description framework with logic. And as we have mentioned earlier, that this logic is the core mathematical concept or framework through which we will be modeling everything, almost everything in the semantic web in a formal framework. So in the next class, we'll be talking about the relationship between logic and RDF framework. Thank you for now.